Hi, welcome to day two of the UE rigging workshop. I'm your host today, Ferris Webby. A little bit about myself. I'm currently a senior technical animator on the Fortnite Battle Royale team. I've been at Epic for a little over 3 years, and before that, I was at various feature animation studios for various lengths of time. But enough about me. We have a lot to go over, and I don't want to waste any time on anything here. So, in day two, you guys have been introed to the control rig system. You've already gone through some demos of building out a rig. We're going to start building out a biped rig on these next couple days, and we're going to do this in procedural ways using the construction event, which is an event that was talked about yesterday, but we're going to be using a lot more today. So in this first day, what we're going to be doing with the biped rig is doing a little bit of a summary and overview of the main events. Then we're going to go in and build the root and the body control, do some FK limb setup, finger setup, IK limb, and then finally we're going to do some IK-FK switching and auto matching to finish up the day. The first part of this is, as I said, just going over a summary of what you guys went over a little bit yesterday. We have three main events in the control rig system. There are other events that will be discussed throughout the week, but we're going to be spending a lot of time in the construction event today to do all this procedural rigging. The construction event runs once when a control rig is applied to a scale mesh. So what it does is it creates all the rig elements that need to evaluate for the rig. So you'll spawn your controls, your nulls, you'll put them into the initial hierarchy, and then you'll use the other events to actually evaluate the rig. So you have your forward solve, which is kind of like something that will be running constantly. So if you're in the control rig editor, you can kind of keep that in your mind that the forward solve is just running if you're in the forward solve mode. We'll be going over debugging of the control rig in later days, but it's not like a one-time evaluation. Since this is a game engine, it runs constantly. And that is where the bones are being controlled by the controls, like what you normally expect with, your everyday rig, where you move a control and the bones move along with it. And then you have the reverse of this in the backward solve, and that's where your bones control the controls. They define where the controls should be. Now, the backward solve is run on a few occasions. One of them is in sequencer. If you bake to control rig, it will use the backward solve to do that bake. So if you're bringing in bone animation into sequencer and you want to bake that motion to a control rig, you could do that, and it uses the backward solve to kind of calculate and solve that. The other time that this runs is if you're using the control rig in layered mode. So you can have a control rig running in layered mode where you have bone animation and then the rig kind of sits on top. So in that case, the backward solve is running, and then some control offsets are applied, and then the forward solve runs with every evaluation. So those are the times that the backward solve is run. So those are your main events. Like I said, we're going to be spending a bit of time in the construction event and the forward solve today, and we're going to get into backward solve stuff in the later days. So let's dive in a little bit here immediately and start building out our rig. We're going to start with the root and body setup. So I'm going to switch over to my engine here. And let me go to I'm in my scale mesh folder here in the project. And the first thing I need to do is actually make a control rig asset so that I could start building out the rig. So to do that, I'm just going to right click on the scale mesh asset here, go up to create, and then go to control rig. It'll create a control rig asset for me, and then I can rename that. We like to use like a CR prefix for our control rigs for non-modular control rig assets, and then kind of the name of the asset. So let's see, robot simple. Maybe I'll put a day2 suffix. You can do what you would like for the naming. So once this is in place, I have my control rig asset, and I can double click to open up the interface. I'm just going to bring over what I opened up. And you can see the interface here. So when you use the create menu over with the right click on the scale mesh, what it does a few things. The first thing it does is in the preview settings tab on the right, it will set your let me move my zoom window out of the way so I could see what I'm doing here. There we go. So it will set your preview mesh to that scale mesh that you hovered over and created a control rig for. So that's one big thing that it does. The other thing that it does is over on the left, if you go over into your rig hierarchy, you see that the bone hierarchy has already been imported for you into this control rig asset. And you can see it's white text here, and that's important. That means that this was done manually in that it's not procedural. It's a one-off type of import. So if you do change your scale mesh, you'll have to go into here and refresh by like right-clicking, or if you want to re-import a new scale mesh, you can do that as well. We're going to be doing something a little bit different with building out the biped rig, which we'll get into in a few seconds. But I do want to point out that white text, and anything that you do in this with the right-click menu, say if you make a, let me just go over a bone and go over and make a new control from here. It'll show up as a new control here, but you see that white text, and that means that I manually created it. But we're going to be creating things a little differently. So I'm going to just delete this right now, that control that I just made. And we're going to hop into the construction event and start building our rig there. To do that, I'm just going to go over to my blueprint tab over here. And you already see there's a forward solve graph, which comes with the creation of the asset. I'm going to make a new graph because we like to keep our main events kind of separated into different graphs. So the graph, you can make as many graphs as you want in a control rig asset, but we kind of usually have a forward solve, a backward solve, and a construction event at least in here. So we do, I'm going to just rename this construction graph. And then you're in this graph here. I'm just going to right click and search for construction event and create it here. And this will be where we're going to start building out our rig and spawning the controls. Oh, by the way, I forgot to, for the panelists that are on here, if people are trying to ask questions, my earphones kind of turn off after a while. So just write on the screen if somebody has a question, and I'll stop and I could.
Can you hear me now, Ferris?
Yes, I can, but at some point it'll
Okay.
cut out. So yeah.
But is there a
Okay.
chance that you can turn your widget screen a little bit bigger, like the widget size?
Oh,
So
yes,
Control
it's
Shift W.
yeah, Control Shift W. I'm sorry. I'll put this at 1.3. Forgot to do that before.
Thank you.
There we go. How's that?
Yeah, perfect.
All right.
Thank you.
Cool. So yeah, so here's the construction event. So what we want to do, the first thing we want to do is procedurally import the skeleton. Like I said, in here, this was manually imported. So to do that, I can just click off of the construction event and use the node called import skeleton. What this will do is it'll take whatever is currently this control rig is applied to. In this case, it's what's in the preview mesh here on the preview settings, the scale mesh, and it'll procedurally import that hierarchy into the control rig asset. So if I look at here, you see the original hierarchy that we've done manually, and then you see the second hierarchy, and that's what's being created by this import skeleton. You can see it's yellow text. So anything that you spawn or do in the construction event procedurally will show up as yellow text in your rig hierarchy. Now we don't want two hierarchies in here. So I'm just going to select root and then go down and shift select all these bones that I manually imported and just hit delete. And that'll fix up your hierarchy. It'll remove that extra suffix that you saw with the duplicate. And now we have this procedural skeletal hierarchy in our rig hierarchy. And then if you update the scale mesh, then it will automatically, when the construction event evaluates, it'll automatically bring in what the current state of that skeletal hierarchy is. Okay, cool. So we have our import skeleton, or we have our skeletal hierarchy in here using the import skeleton. Now let's start building out our controls. So the first control we want to build is the global control. So let's start doing that. Now the one of the first things I normally do, with the exception of this import skeleton, because I kind of like it to be the first node, is to put a sequence node at the start of any event or function. So what the sequence node does is it provides a way to have these little pins so that it can connect to, and we can read each step horizontally in, say, an event, but the whole process vertically. So we like to do that internally. So we like to just start with this sequence node for a lot of things. You'll see me doing that throughout this. So from the A pin here, I'm just going to go and we're going to start building our controls. And the first one, like I said, is going to be the global control. We're going to use a spawn control for that, or a spawn control node right here. And let's look at this node. So what this node does is based on a configuration, it will give you a control. Currently, it says it's error. There's an error, and that's because this node can make different types of controls. So you have to tell it what type of control you want to make. If you look down here on the initial value, you see this gray coloration. That means it's a wild card. So anything that you see, any node that you see with that coloration, that node can work with different data types. So in this case, we can make different types of controls. The global control will be a transform control. So to define that, you just right click on the initial value, and then you get this pull down where you can select the type of control you want to make. So I select transform, and now you see the control show up at the origin here, which is great. We got something visible in our viewport. We still have a lot to do, but it's fine. So let's go to this node and go over some of the configuration that we can now use in here to better specify what we want for the global control. First, we have a parent. Now, the global control will be in world space, so we don't need to link up in a parent, but we will be using this later. You have a name. So right now, if the control is named by default, it's called new control, and you can see that correlating to the name field. So I could just rename this to global. Whoops. And you can see that change to global when I change that. You have an offset transform, and in this case, we're going to just have this at the origin and world aligned, so we don't really need to pump anything into there right now. We'll be working with offset spaces a bit in this session. So I normally query in global space. So one thing to note is when you're working with maybe not specifically this control rule, but maybe others, to make sure you're querying and you're setting in the same space. So if we're going and querying a transform somewhere in global space, you want to set it or use an offset space of global for the spawn node. This is the same is true with anything where you're saying setting a transform, maybe using a set transform node. But it's something that I definitely forget sometimes, and I get confused as to why something's not showing up in the right place. And that's definitely something that has come up. So keep that in mind. All right, and then down here, there's the settings pull down. And here you can specify a bunch of other stuff. You can see there's a rotation order that you can enable, and you could specify a specific rotation order if you want. There's a lot of things you can do here. I'm only going to be doing certain things that I have time for, but you can take the asset on your own and configure it as you wish. We're going to go down to the shape here. Oh, I should also mention limits. I don't know if this was mentioned yesterday, but with limits here, you can actually limit the manipulation of certain channels and transformations. So translation, scale, rotation control. But we're not going to be doing any of that as well today. Just wanted to note it that you would want to do it in here. But let's go to this shape pull down. And what we want to do is we don't want this default red sphere. We want to configure this a little bit. So the name field for the shape, we're just going to make this a rounded square thick. And you see that it actually did it. It's like super small though. So that's another thing we're going to have to configure. So whenever I'm like scaling a control, I like to select the node and go over to the details tab over here. And that's because, first of all, when you select the node, you could see a corresponding list that you see in this node over here. So you can work in either place. But down here under the shape pull down, by the scale, there's this little lock. And when I'm scaling up or down controls uniformly, this is nice to have. So I just click the lock here. I know 8 is a good number because I've done this before. So that will be my new scale. Now, I'm setting a scale here, but it's not affecting the animation axes. This is literally affecting the control shape. So in other DCCs, if you select the CVs or verts and you rotate them or move them, that's kind of what this is doing. You have this handy little transformation here to do that with. Okay. All right, cool. So we have this here with the shape and the size, but the color, I like my center controls to be yellow. So I'm just going to go into the color here, and I'm going to click on no for this. But then I'm going to set this to a yellow color. So let's do that and then hit OK. And that sets this to a yellow, right? So that's kind of what I want. Now, this color I might want to use on other controls though, because as I'm building out the rig, we might have other, of course, we're going to have other center controls that I also want to be yellow. So this is the first time we're going to dump a pin to a variable. We're going to be doing this a lot in this session, and it's really a handy thing to do. So in this case, what I want to do is click on the color pin here, drag and release, and then you have this option to promote to variable. So if I select that, it gives it this procedural name, which will change. But if you go over to your My Blueprint, now in the variables area, you'll see that is there. And I could right click and rename this to center control color. So I have that named nicely. And if I compile and save, the error goes away. Everything's still yellow. And if I select this variable, you could see over on the right what the default value is. And that's that yellow that I initially configured here. So I could use this variable on other center controls, which I'm going to do right now, actually. I need to create a local control now, which will be a child of the global control. So what I can do to do this pretty quickly is I could just select this spawn transform control, hit Control D to duplicate it, and then connect up the execute pin. And now configure this guy to be the local control. We want it to be a child of the global. So the way we do that is on the spawn nodes, you see this little output. This is a reference to what was spawned. It's a rig element. So a rig element has a type and a name, and that'll be important a little bit later, but just know that it has those two fields as part of the struct there. So to uh, connect this up as the parent, I just click and drag this over to the parent input of this new spawn node. And now if I compile and save, you'll see we have it now as a child of global. The name's entirely wrong though, because there's already a global, so it's adding in a suffix of _2. So we're just going to change that to local. So now we have a local control as a child of the global. You don't see it here because it's right on top of the global control. So we just want to actually configure this with a slightly different scale. So I'm just going to select the node, click on this lock, and bring this down to say 6. Cool. And then what we want to also do, just in case we want to change the color of the center controls, like I said, we have this variable that we can use, right? So I'm just going to click and drag this off of here and input it into this node. And then if you double click on a noodle, you get this little reroute node here. And we're going to be using these a bit too to keep the graph clean. You can see you can kind of double click, move it down, and now it's like really nicely readable. And we like to keep a clean graph. I'm going to be doing a bit of graph cleaning in this, but not everything. After you get stuff working, I usually spend a bit of time just cleaning up the graph and making it readable. One thing I should mention that I forgot to mention when I made the sequence node and started this row is I do like to put a reroute node here by double clicking right by the first node. And I'll show you why later once I start adding in the comment blocks, but I do like to utilize that process as well. Okay, so we have a local and a global. The local is a child of the global hierarchically, so you can see that happening here. And you see the local, you could also move around, but it doesn't really control anything. So that's a problem. We got to fix that. Now, to make it control something, what we need to do is add some logic to the forward solve, because that's what the forward solve is for. It's for the controls to drive the bones. So let's go and do that. We're going to head over to the forward solve. Now, I have the tab up here, but you can get to it over here in your My Blueprint as well, just by clicking on the forward solve. And we're going to start this just like we did the construction event, not with the import skeleton, but with the sequence node. There we go. Cool. Now, how do we want to drive the bone here? Well, we want to have it so that we know what control we need and then what bone we need, and then do some sort of like get and set. Or thinking about yesterday, in James's presentation, he kind of already wrote a function that does that. So we're going to go and steal it from him. So I have the Omega CR asset here. And I see the function here is called FK control chain. I'm going to right click, copy that, and then go over to my asset and go over to the functions, right click and paste function. I'm going to name this forward FK, and this will be my function for any type of FK chain that I need to solve in the forward solve graph. So I'm going to take what James did, and I'm going to edit it a little bit to make it a little bit more procedural using some of the construction event stuff that we'll be adding in as well. So let's take a look at this function. We have a bones array input and a controls array input. What I want to do is instead of having those two inputs, I want to actually track the controls through the bones using what's called metadata in control rig. So let's start doing that right now. First of all, I want to get rid of this controls array input. So I can just select the entry node, go over to the right. If you don't see these X's on the right, it might be that this guy is too narrow. So you just got to expand it a little to see it. So then you could just click on the X, get rid of the controls, and then we also use the controls input here with the at node. So we're going to also get rid of that. But we're going to keep everything else for now. So this function will basically loop through the bones, somehow get a control for each bone, and then get a transform from that control, and then set the bone transform, okay? So that's what we need to do, but we need to figure out how to track the controls. So if we go back to the construction event, what we can do for the local control is add some metadata to the root bone saying, hey, the local control is what's supposed to control you, because that's what we want here in this rig. So to do that, I'm just going to click and drag, and we're going to create a set metadata node. And this node will take in an item where you want to put the metadata on. It will give it a name of the metadata, and then you give it the value. Now the value is going to be the control. So we're going to be putting metadata on the bones, and then the value of that metadata will be the control. Now the control is this local control. So there's this output here, item, that is a reference to that, like we did over here. We used it as the parent for the local control. And we're just going to click and drag that into the value here. And then for the item, you can actually just expand this. It's already set to bone for that rig element. Remember, it has type and name. And then in the name, you can search for root and then just select that. And then we have to set a name. So for this, I'm gonna call it control. That's the name of my metadata. And that just says, hey, this is the control for this bone, basically. That's what I'm kind of making a system that does that. So I'm just gonna compile and save this. Now, I wanna show you, if you select the root right now, the root bone in the rig hierarchy, you can now see there's this metadata section, and that's where this value is coming from this set item metadata here. So it's saying that, hey, this root bone, this local control is supposed to control you. And you can see the name of the metadata right here. So you can see all your metadata in this area if you want to confirm it's actually being made. So we have our metadata. This is great. So we can go back to the forward FK function where we're cycling through the bones, right? And what we need to do is from that bone, get the control, right? So we're just going to click and drag off of this and say get metadata. And then we have to select what metadata we want to go and get. So we want the control. And let's, all right. And then from here, the value output is going to be the control, the local control. So that's what we want to do with this connection here, where we're getting the transform from it. Cool. Now, we have this kind of set up, so let's try it out. I know this is going to break, but that's okay. We're going to figure this out and how to fix it. So let's go to the forward solve here and put in this new function that we created, it's forward FK. We're going to add this in for the local control to drive the root. So we're just going to connect up the execute line. And then in the bones, I'm just going to click this little plus sign. And I'm going to select this as bone and I'm going to put in root. Oops, root. And there we go. And it's wrong. The robot is dead. It's okay. We will bring it back to life. And that's because in the forward FK, the local control is world aligned. The bone is not. So there's a different orientation there. And in the forward FK, what we're doing is we're just taking a straight transform in global space and we're setting the transform over here in and if there's a difference in orientation, you're going to see that difference in orientation in the result. So we can't use this get transform, at least for the local control. So let's use another node that will be kind of like this, give me a transform, but be more of a, give me like a parent constraint with a maintaining of an offset. And that node is project to new parent. So I'm just going to search for that, create it. And there's a bunch of inputs here. That's okay. I'll explain them. And it spits out this transform. So the purpose of this node is to take in a parent and a child, and it takes in the two states of the parent, the initial state and the current state. And it will then derive what the current state of the child should be. So it's just, like I said, it's like a parent constraint with a maintain offset in there. So let's connect these inputs up. The child will be the bone, so we're just going to connect that up to the child, and the parent will be the control, which will be coming out of this get item metadata. So we're just going to connect these up to both the old and new parent. You can see these are already set to gather the initial and the current. Like I said, it gathers the two states and it uses that to calculate the orientation difference and calculate the current transform that should be for the bone. So now we have an output transform for this. But how are we going to keep this guy in here also being used in the function, but also use this when we want to? Well, we're going to use a node called if. So if I make that node, you can see the gray coloration again. So based on a condition, it will give you either a true or false result. And this node deals with different data types, as you can see with this gray here. But if I connect from the transform outputs, it'll kind of auto qualify that. So let's think about this. So based on a condition, so let's make a condition, a Boolean value that's called maintain offset. So if maintain offset is true, I want to use this project to new parent because I know that there might be an orientation difference if I want that, and I need this node instead of that one. And then if it's false, I don't care about maintaining the offset, so I just want to straight get and set. So this will just be connected to the false, right? And I'm just gonna reorder this just so that the graph looks a little better there. And then the output of this will then go into the input of the set transform. Now, we still need this condition, but as you can see here, if I click true here, then the robot comes back to life. And if I select the local control, nothing is happening right now. And that's because we need to go in and see what kind of input we're doing here for the get metadata. Ah, yes. Okay. So if I go into here and I'm setting the name here to control, that is correct. Maybe I put a space on it. Huh, interesting. Let's do this. Let's go back to the forward solve here and see if we have all the inputs here. So we have the forward FK here. Let's go into the FK here and see if something is wrong here. We are doing that. We're getting the transform. And we're doing that. Interesting. Well, let's make them maintain offset condition first. So we're going to make an input to this function so that we can specify in the forward solve that we want to maintain the offset, which we don't have right now. So we want to do that first. Let's do that, and then we can go back and look at to why this is not driving the root. So I'm going to click drag off of this, go up to promote to expose pin, and I'm going to select the entry node, and I'm just going to call this maintain offset. So what I just did is an easy way to add in an input to the function here. So I'm just, like I said, I just clicked it, dragged it off, and then there's this promote to exposed pin. What it does though is it creates this connection line all the way over to here. So what we like to do once we do that is we like to click this here off of here and go and say get maintain offset. Cool. So now what this is doing is actually gathering this input directly, and it will be setting it in here. But it keeps like the graph a bit clean in that state. Okay, cool. So we have oh, we didn't set the bones probably. That's might be what's going on here. Yeah. All right. So let's go back and make sure that that is happening. So in here we have, well, we do have that. Let me check this real quick. So we are doing this. We're going through the bones and we're getting that from there. Good. And we're getting the control and we're doing the control, we're getting that transform. And then we're setting the item, which should be the root bone here. As to why that's not working. And this sometimes is the case where something you miss and you just got to go back and fix it up.
I think
In the
Ferris, you might
construction
want to.
event, we are setting the bone, the root, name, control. That's interesting. Hey guys, did you see that if I did anything here? Oh, I didn't.
You hear
No,
me,
no, I
Ferris?
did set that.
Can't hear me.
Ferris, can you hear us?
Control. That's the control. Oh, is my thing off?
Can you hear us now, Ferris? Hello?
Okay. Yep, I can
Can you
hear
hear
you.
us?
Yep.
I, I think it might be that in your forward of k function, you're just using the old get bones and maybe the variables haven't come through properly. I'm not 100% sure why
Oh,
it's not working. I feel like it should be
maybe.
working.
I feel like it should be too.
I mean, I've got exactly the same setup and it's working.
Mm-hmm. Well, let's try it. Mm, yeah,
I think there's some issue with the metadata there because it's still having the control thing on red.
it is. Yeah, yeah, yeah. Let me close this and reopen. There it is. Okay. Something happened with uh the the metadata there. I'm not really sure what, but let's just, oh no, 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 it's still doing that though.
Maybe just remake that
There
node.
we are.
Oh,
Yep, no.
there we go.
Yep, yep, yep.
Okay.
So I'm not really sure what happened with the metadata there, but this is how things should work. Sometimes just closing and reopening the asset will kind of it'll figure out things and it'll work. But this should be the correct setup here, where we're just getting the metadata. And as James said, the tip was that it wasn't showing up in this pull down. If you create metadata, it should show up there. So something must have been wrong.
I mean, what you just did is change the name, so it must have been a space or something in that field that you by picking it, like a typo that you couldn't see. Like it's gonna be something like that
Yeah.
because it was red. Yeah.
Yep, yep. So be careful, I guess, is the rule here. But yeah, so now sorry about that. We now have a working local control. Global control is still the parent of the local. I can move that around, no problem. Cool. All right. I'm going to try to speed up this up a little bit so that we can not lose a lot of time. So we have the global control and the local control, but now we want to build a body control. So to do that, I can just duplicate this guy to start off. I can move this over to here. And I want the body control to be the child of the local control, right? So I'm just going to double click on the noodle here to make another reroute node, and I'm just going to use this as the parent. And I'm going to call this body instead of local. So if I go into the rig hierarchy, go down here, you could see now global, local, body. So that's great. You'll see me compiling and saving all the time. It's just me. I'm just kind of neurotic like that, where I like to make sure I have everything compiled and saved. So I have the body control here. Now you don't see it because it's on top of the local control. So that's another configuration that we want to do. So we just select the spawn node here. I'm going to go in and I want to, first of all, well, you know what? I'm just going to change the shape. So I'm just going to in the spawn node, I'm going to change this rounded square to hexagon. So when I do that, you can see it right there at the origin, which is the incorrect position, but we'll fix that. So I'm going to give some space here. So what do we want to do? We want to actually put the body control in between the hips, right? So I can just select the select these hip bones here. You can see it in the rig hierarchy. I can click, drag it, go to create item array. And now I have this item array here that I can use now to calculate like an average position between the two bones. So from this output, I'm going to click and drag, and there's a node called get transform array. And then from here, I need an array of positions. So we do have a node. If you search for SRT, there's a transform array to SRT. All right, cool. So now we have this array of translations. So all this did was it took the item array, create a corresponding array for transforms, and then broke those out into corresponding translates, rotates, and scales. And then we have a node called average for arrays. Whoops. There we go. And now that we have that average location, I can go over to this offset transform, spin it down, and then I can connect the average output to the translation input here. And you can see once I do that, the body pops into the middle between the hips, because that's where I want my body to kind of bend from so that there's no buckling in the knees or anything, and it bends around that axis. Cool. So we have that in place now. So now we want to take this and drive the spine bone by that body control. So we already have this forward FK written, and now it works now that we figured out the metadata. So we can go over to the forward solve now, and we can basically have control the body control or the spine bone by the body control. But there's one thing we need to do here. Like we did with the local control, we need some metadata. So let's just duplicate the forward FK first, connect it up, and then instead of root bone, this will be spine first. And if I do that and I rotate this, nothing will be working like it was before, but this time there's actually, I know the reason. So there's no metadata for that bone yet. So we have to go to the construction event and just make it. We're just going to use like that set item metadata node, which is called set metadata. And we're going to put this on the spine first bone. So from the bone, we're going to search spine first. And then the name will be control. And now I see it in that pull down. So I know everything is working correctly there. And then the value is going to be this body control. So I'm just going to click, drag that over to the value. And now you see that pop into place and everything works as it should. The body control will control that spine bone. And you still have the hierarchy in place here where the local control will also move and the global. And you see the hierarchy is correct down here as well. Cool. So we have the global, local body. So now let's start building out the ARM FK controls. So what we're going to do is, let me just make, well, it has a little bit of space. Maybe I'll make a little bit more space. So I'm just going to click and drag these nodes and move them up this. So what I want to do is make like we have with the forward FK function, I want to make a function that will take a set of bones like the forward FK does, but then create a hierarchy of controls. So let's actually start from the forward FK function. So I could just right click, copy, and then right click and paste. And I'm gonna call this construct FK. Okay. And we'll make a few adjustments here. We're gonna delete most everything here, with the exception of, well, we don't need to maintain offset, but we want the bones input. And we're just gonna still loop through bones, and we're gonna be creating controls for each bone, okay? So let's start doing that without really thinking about it. I know we're going to be iterating on this. So if you're going through a bone, what I want to do is spawn a control for it. So I'm just going to click off of this and go spawn control. so that now that it'll, for each bone, a new control is created. Now we still need to set what type of control that is. So we're gonna need to right click on the initial value. We're gonna make this a transform control. There we go. Now we don't see anything in the viewport because we're not really calling this function yet. So let's go back to the construction event now. And I made broom here from the other nodes that I used. And I'm just gonna bring in the construct FK here. And I'm gonna connect the B pin to that. Now we're gonna need a bones input for this. So to do that, we need the arm bones. In the viewport, I could just select this first arm bone, and I can, shift select or control select the other three, and then I can click and drag that into the viewport and go to create item array. That'll create an item array like we did with the hips, but this time we're gonna actually dump this input to a variable so that we have this like setup variable that'll be used later for, say, the other side of the body for the right arms. So I'm just gonna click this and drag off it and go to promote to variable. And then go over to the blueprint and right click on this, rename this to arm bones. And we can then delete the item array. So at that point, when you compile and you select your arm bone variable here, those items that you selected in the item array are in this variable. They've been dumped down to that variable. And now I can connect this into the construct FK, right? And now you see something happen in the viewport. It's the wrong thing, but it's fine. It's something. So you see these spheres down here, and they're all showing up just down here because that's all it knows what to do. It just is creating a control for each bone. So we need to tell it, where those controls should go, and also the parenting structure as well as the name, the naming there. So I'm gonna double click, go into the construct FK, and we're gonna set some of this up. The first thing I want to do is make sure that they're like placing into the right location. So in my bone loop here, I'm just going to click off of the element and I'm going to get a transform from that. And then from there, I can take the transform and bring it into the offset transform, like so. All right. And you'll see it does go into here, but we do want the other thing that this spawn transform has is a parent, and we kind of want to define that parent, that initial parent where these controls will exist. So naturally speaking, that'll be the clavicle. So let's actually expose this parent input as a pin to the function so that we can fill that in. So I'm going to click and drag off of this and say promote to expose pin. And then I'm gonna click off again and say get parent. And make sure you're selecting, we have a get parent node, make sure you're selecting the get parent from the input arguments. So we have a parent here. It's not set yet, but that's okay. We can go to the construction event now where we're using this construct FK, and we can set that parent to the left clavicle. Now something will go wrong here. So if I compile, save, you see these controls are way not in the right place. And that's because this offset space where I'm connecting in this offset transform is set to local space, but I'm querying in global space. So I want to set this to global space. And now they pop into the right location. They're actually in the hierarchy. They're in the right location as well. This is also a good time to note that anything in the construction, a good practice is when you're querying a transform, say with this node here, you want to set this initial to true. And this is also true for anything else in the construction event. So for example, when we're doing the body control, I didn't set that when I was getting the transform array. You'd want to set that as well so that it's getting the initial value for the control. All right, so let's go back into the construct FK because we got some more things to do. I like my parent to be at the top. So if I select the entry, if you go over to the right, you can set the order of these inputs by using this arrow. In the later builds, you don't have to do this. You can click and drag the order, even on the entry node. But for the 5, 6, you'll just use these arrows here. So parent, it reorders that, which is great. And now let's see what else we need to do. So we have these three controls for the bones. They're named improperly. They're not in the right hierarchy. So let's fix the names. So the names, I mentioned the rig element key type here. So we have a type and a name for each element. The name, we could technically just take this name and pump it right into the name of the control. And that'll build a control with the same name as the bone, which is totally fine. And it actually is a really cool feature of control rig. So if things have a different type but the same name, they are seen as unique. So nulls, controls, bones, they can all have the same name and still be seen as unique. But we don't want to do that. Internally, we like to use a naming convention where we're using space separation with a uppercase first letter. So we're going to be utilizing a function here. I'm going to cheat. I'm going to go over to my finish day 2, and I have a utils function called conform name. And again, this is in the day 2 folder. So if you go to day 2 Ferris, you'll see the robot day 2 in here. So I'm going to copy this, and then I'm going to go over. Whoops. Let me bring that back. Let me bring the window back over, and then go over to my blueprint. Right click on the functions and hit paste function. And there you go. Now I have the conform name in here. It's under this category called utils, and you can see over on the right, you can set categories for functions and variables. I'm going to be doing that later to kind of keep things a little bit more organized. But for right now, this conform name, I'm not going to get too deep into this, but what it does is it splits out all the substrings separated by an underscore. It capitalizes the first letter, adds them to an array, and then it uses a join node to join all those elements of the array with a space. And that's what it's for. So let's try and utilize that. We're going to go over to the construct FK. We're going to click, drag conform name into here. I'm going to link this up to here. I'm going to connect the name up to the source name and then the result to the name. And when you do that, now you see everything's been conformed based on the bone name, but we conformed it to control naming standards. Cool. But now we still have a hierarchy problem, right? So we're using this parent here, which is an input here, and it's a constant. It's using it as a constant. But we don't want that. We want to, every time a new control is spawned, what we want to do is overwrite that parent, like and have like a current parent as it's running through the loop. So to do that, what I could do is click and drag off of this and say promote to local variable. So this local variable will show up in my blueprint down on this local variables area down here. And the purpose of this will be keeping track of the current parent. So we're just going to rename this to current parent. Okay. And the reason I'm doing this, you could always just click the plus sign and make a new variable. But what's really convenient about going off of pins is that you get the type of variable automatically, the proper type that you want. So I do that a lot. And one of the reasons is because of that. So we have this current parent. We're going to use that current parent for every spawned control, but we do need to set it initially. So before the loop, what we want to do is add a set current parent here. So you can just type in set current parent and you select it. It will maintain these execute connections in here. And then you can take this current parent or get this get parent, which we're getting from the input of the function, and look and connecting it here. So it sets it initially before it goes into the loop. And then it uses that current parent for the spawn. And then after it spawns, we need to do another set current parent. But we're going to be setting it to whatever we just spawned. So when we do that, compile and save, we're going to go over to the rig hierarchy. Now you have the proper hierarchy here. So we're just going to take a look at this. So everything is kind of moving hierarchically in the right way here. We still have some configuration to do, but we'll get to that in a minute. But we have all the right naming and hierarchy and everything else. Okay, so let's configure the control a little bit. So in the settings, like we did with all the other stuff, go down to the shape, and we're going to change this to circle, thick, And let me just compile this, just recompile it to see what we have for the orientation here. So the orientation of the shape is a little off. So we just go into the spawn node. I'm going to add in 90 degrees to Y to get it into this orientation. Again, this doesn't change the animation axes. It's really just rotating the control shape. And that's cool. I don't think I need to set the scale. I think that's it. So what I want to do is now expose this, these shape settings as an input to this function, so that outside of the function we can configure different shapes if we want to. So to do that, I'm just going to click on the shape pin, click off, go to promote to exposed pin, and the function, I'm going to call this pin shape settings. Cool. And we're gonna then do a get shape settings here. Or sorry, I could just click off the pin and do that. Just to get rid of that noodle that's going across the function. Awesome. So now we exposed it in the function here, and I like my shape settings on the bottom, so that's great. If I compile and save and then go back to the construction event, I now have that shape settings exposed. So I can go and change things if I want to. Now, the one thing I do want to change, well, first of all, there is a little bit of a visual bug here where I need to go back into the transform and apply this 90 degrees. There we go. So these are oriented correctly. But the other thing I want to do is actually set a color, right? So I can do this by, well, I can do this a couple ways. I can set the color in here to, this will be my left color. So I want to make it blue. So let's do that. And then if I click OK here, I want to set this as a variable, just like I did with the center control color. So I can click, drag this off, promote to variable, go over to my blueprint and rename this to left control color. Now, the other way I could have done this is I could have just selected this and duplicated the center control, changed the value of it, and then link that into the color here as well. But now I have a left control color, which is really cool. So we have this all constructed. So now we need to go in and make it so it controls the right bones, these controls. So let's go into the forward solve and see what we want to do there. Again, we have this sequence node. And we already have this forward FK, right? So we could probably reuse that again, or you could duplicate it. You can drag it in from here. You can search for it. Many ways to do that. We need the bones, which we already have as variables, these arm bones, right? So I could drag these in here and say get arm bones. Go into there. And now, if I compile and save that, nothing will happen. And why? Well, because that forward FK needs the metadata, right? So we'll just go hop back into the construct FK and we'll add that metadata in. We'll just connect up a set metadata here. And it's going to be on the bone. So we're looping through the bones. The control will be the spawned control, or the value will be the spawned control, will be this item output. And the name will be control. And you can see it already work. It pops into place when I compile, or when I went back to the viewport. But I'm going to just recompile, save, just to make sure everything is working now. So now we have a fully working FK arm in here. And that's because I'm still using the forward FK, but we have the proper metadata for those bones being set. Okay, so we have the main controls here. We have the forward, the ARM FK controls in place and working. We're going to take a little break, and then when we get back, we're going to do some little bit of graph organization, and then get into some finger control setups, which will be really quick to do now that we have these functions, and then start getting into the IK ARM. All right, cool. And we'll be back, I don't know, in 10 minutes. Is that okay? Is that what we usually do? Okay.
Yeah.
All right. I can't hear you. I have to
that
turn
works.
on my headset again.
Yes, I believe that works.
Okay, that gives me 10 minutes to say, go, Ferris, go again. That's
There we
great.
go.
Where are you, timer? Oh, I'm not the host.
Am I the host?
Who is the host?
Am I the host?
Oh, I am the
My
host.
host is
Of course
Ferris.
you are.
So
Yeah,
for
yeah.
Ferris, I
Can I-
believe under more, you should see the option to create a timer.
Oh, wait, I think it's under apps, isn't it? Oh, I can do it.
Is it?
I can. Oh, can you make
Oh,
it?
there it is. Yeah, yeah,
All right,
it's
cool,
there.
cool. All right.
But it's very
Awesome.
slow, but I'll.
I got it. 10 minutes, you said?
Yeah, 10 minutes is fine. I'll try to make up time in the next session with certain things.
Yeah, stop breaking things, man.
I know. That was the first time that ever happened. I was just like, what is going on?
Stop my video. So the timer goes away.
Alrighty. Cool. Let me just share my screen again. We did have a question about why we're using the metadata in this example and demo. Metadata is really cool to use because you can kind of embed it into pieces of your rig, bones, controls, as you'll see, even animation channels, and then just query it later anywhere in the graph, wherever you have, access to those bits of rig. So it kind of eliminates any scoping issues, I guess, if you are passing data variables through functions. So, it's not wrong or right to use metadata or variables to kind of manage your data. We use metadata for certain things internally, variables for other things. Even in a modular rig setting later on, you'll see it might make more sense to use variables over metadata. So, yeah, that's kind of, I hope that answers the question of what it is and why we're using it. It's just a way to pass data through the graph freely and register things that are kind of closely connected. So, for example, the bones to the controls, and later we'll be doing something else with the IK that does that kind of thing. Okay, so let's get back into here. So we built some of this stuff out, but what I want to do now, because I built it out, is start just organizing the graph a little. I'm not going to do this entirely. I don't have time for it, but I'll show you what the process is that I usually take. So we already have these sequence nodes in these rows, but we do like to comment our steps. So let me just zoom in here so you can see things a little better. And if I select a bunch of nodes and hit C, it creates a comment block. And then you can double click on the comment and say, so this is the forward solve. So this will be solve, root, and body, or something like that. And then you can colorize these as well. And internally, we have little color standards here. We're using a specific coloration of certain things. For forward solve, we've decided in the demo to use a green for any forward solve stuff. So I just go over to the right, and in the comment color, I just set that to green. And then you could also select more than one at the same time and then set your color as well. But I also wanted to show if you are creating another comment block, and this is like solve, what is this, left arm, right? You can then copy from this. So you can go over to the right click, copy, select this guy over here, right click, paste to get that same green color. And then in the construction event, we can create a comment block for this and another one for this. Let me zoom in a little bit and move this over here. Just resize that and move the noodle over. That's why I have this little reroute node at the beginning of the blocks, because if you have them there and you move the block around, it kind of keeps that noodle out of the way. So that's the reason I do that. But here we can just do, we can double click on this comment here and say construct root and body. Let me zoom in a little bit. It really doesn't matter. These are just for you. Construct left arm. Okay. Then, like I said, you can select more than one of these. So I could shift select this, go over here to the comment color and set these both to, for construction, we're going to use blue. And then you hit OK and everything's good. Okay, cool. So I do this for a lot, and at the end, when I have everything working, I do a lot of graph cleanup so that it's easily readable. So we have different comments in different the major steps of the process. We have colorization, and we still, like I said, use these sequence nodes to read vertically. All right, so we have the FK arm. Let's extend that and start making the FK controls for the fingers. So we already have a construct FK function, right? So let's use that for the fingers as well. So I'm going to drag that in here. But what are we going to need here? So we're going to think about this. We have multiple fingers. So what I want to do is I'll take the base bones of the fingers, store them away, and then loop through those and get the children. And then I could then use that as a way to pump that into these the bone inputs here for the construct FK. So let's do that right now. We're going to go over to the rig hierarchy, or you can select in the viewport. So I could just select this index. So I'm going to select all these base bones. So let's see, thumb, control click index, control click middle. I'm going to drag this out, create an item array, and then I'm going to dump this to a variable so that I can register these as finger bones so that I can use them later on the right side if I wanted to, and just augment the list of items because these will be the left side ones. I'm going to delete the item array and go over to my blueprint and just rename this to finger base bones. Cool. So now I have the base bones, and as I said, we're going to basically create a for loop here that goes through the base bones. So I'm going to start with a for each node. I'm going to put the base nodes into the input of the for loop, and then for each base bone, I'm going to use a node called get children. And that's exactly what it's described as. So it gets the children of whatever you have there. And I want to include the parent into that list. So we want the base bone in there as well. And then after that, I'm going to connect the for each into this construct FK. I'm going to set a parent, which will be the hand. So L arm hand and then I'm going to connect up the items to the bones. And I'm going to compile and save that. And you see those are now constructed. And I have this shape settings that we exposed where I can now configure what I need to configure. So I'm going to select this, the shape settings over here. And I'm going to remove that 90-degree rotation. So that should give me that. And I'll probably use this little lock again to bring these down to maybe 0.5 of scale. The other thing we need to do is the left arm. So we need the color here. So that's where I'm going to use my variable for that. Get left control color. And I'll connect that right into the color for the shape settings. And now you have nice blue controls for your left side. Awesome. And you can put a comment block over this saying construct fingers now, just like I did over here. But they're just constructed now. So let's now go over to the forward solve and do the actual driving of the bones. What I could do here is actually, most of this is going to be the same. So I can just copy this, go over to the forward solve, paste it, connect this up to the for each. So it's still going to get the children there, but we're not going to use a construct FK this time, right? We're going to use, and we don't need the left color because this is the forward solve. We're not defining any colors. And we're just going to use the forward FK here. And I don't need to maintain offset. That's another thing. I set this as default to maintain offset in the function. You could set that to off because if you want, or you want it as true for default, it's your choice. To do it, you just have to go into this function and set the value on the variable and hit compile, and that will reset the default or the input variable, I guess I should say, the input of the function. But for here, what we want to do is we're going to put maintain offset to off because we don't need. We're going to building just like the FK arm. There's the same orientation, so we could just do a straight set, get and set of the transforms. So we're going to just connect this up, and we have our children, getting our children here just the same way as the construction event. We're going to put that into the bones. And because we already built in all of the metadata into these base functions, we immediately should have working FK fingers. So it's that easy to kind of extend what we did initially in the last session to now reuse it in other parts of the rig. And we can get a real quick FK hand with the usage of just a few more nodes, a couple nodes, and the usage of those functions. Cool. So we have fingers done. I'm gonna, can somebody talk, James, to see if I can hear you? Just to make sure my headset didn't turn
Can
off.
you hear me? Can you hear me?
Yes. Okay,
Hey,
cool.
that's good.
I just want to make sure I can still hear you guys.
Test
All
1, 2,
right.
3.
You got
Test
it.
1, 2, 3.
Yep. I got you. All right, cool. So now, now that we have the fingers, let's move on to building the IK controls of this arm. Okay. So we're going to go over to the construction event, and you see here we have this construct FK. Now, this is great and all, but I kind of want to have a function that builds the FK controls and the IK controls. So we're going to make it a construct limb and use the construct FK inside it. Now, to do that pretty quickly, you can right-click on this function and use a feature called collapse to function. What this will do is it'll make a new function. It'll put the function that was there inside of that, and it'll kind of try to maintain inputs here. Some of these will change around, but we have this new function here that I'm going to rename construct limb. Cool. And then we'll go into that function and kind of just organize it a little bit. So we have this is what was out there before, the construct FK. And I'm going to do what I did before with starting with a sequence node. I'm going to connect the B up to the return of the function so that it's always kind of at the bottom of that sequence node. And I'm going to connect the A up to this construct FK. And then I don't want these noodles here, so I'm just going to do a get bones, just so that from the input arguments, just to clean up, to keep the graph clean here. So I'm going to do this, and I'm going to do the same thing. Well, for this, actually, I don't want the color as the input. What I want to do is change this up a little bit. So I'm going to get rid of the color input here. And as I said, if you don't see that X, you might have to do that. So I'm going to remove the color input, and I'm going to expose the shape settings instead, the whole shape settings here. And we're going to say promote to expose pin, and then we're going to call this, since this is a construct limb, this is my FK shape settings. And then I'm going to just, again, click off the pin and say get FK. And just a quick note, during the last workshop, I believe in probably Hellgate 5.8, we'll have an easier way to do what I'm doing a lot here, where I'm exposing, promoting to an exposed pin, but then making a get node for it. I think we'll have a one-click solution for that in 5.8, which will be awesome to have. Cool. So we have the get FK shape settings here as an input. That's what we need. Let's just make sure we go back to the construction event and reconnect the right things here. Color goes into the FK shape settings color. And then again, I think we'll just need to go into here and remove the 90° from there. Oh wait, whoops, did I do that in the wrong place? Let me see. Oh, I didn't connect. Yeah, I did. I connected it up there. Yeah. Let me see what I got here. Let's go back to the the construction event, and make sure that we have these all connected. And there we go. Yeah, that was that visual glitch where you had to like zero it out and then put 90° back in. I think we'll look into that to fix it on later builds. So we have these all working as they should. This should still work with FK. So it's constructing the FK controls in the way we want. So that's great. We have that where it was before. So we don't need to touch any more of that. Oh, but we do need to expose. So here we have this hard-coded clavicle for the parent. So we will need to expose this for the construct limb so that we can kind of configure that. So I'm just going to click off this, go to promote to expose pin, and then do a get parent, like so. Remember to take the input argument one, connect that into there. And now we have this parent here that I'm gonna just reorder. So I want it kind of above the shape settings. I like my shape settings on the bottom of the inputs. All right, now we're all good because now if we go over to the construction event, this parent should still be at alarm clavicle, and then any other construct limb nodes, we can configure that parent in there. So let's go back into the construct limb and let's start building the IK controls. To do that, we're going to need another pin for the sequence. So I'm going to add it here, and I'm going to hold down control, click, drag off, and then release on C to just shift this down. This is another thing that I think we'll have a right click type of feature in the later builds here to add like a pin above, which will be awesome. All right, so let's start building the IK. We need three things here. We need an IK control. We're going to need a child null that'll work with the forward solve and the IK effector input for that, for the IK node that we're going to use. And then we're going to need a pole vector control. So we're going to build all those here in the construct limb. So let's first pull off of B, and we're going to use another spawn control. This is going to be a transform control. So I'm going to right click, go to transform. There we go. And it's down here, right? Which is not in the right place. So the IK control needs to be world aligned but snapped positionally to the end bone. Well, we already have the bone inputs here, right? So I'm just going to use get bones to get those inputs. And then I'm going to use an at node. And I can use a -1 for the value, just like if you're familiar with Python, -1 just means the end of the list. So I can use that to get the end bone. You could also hard code the index number of the array for that. And then from there, I'm going to get the transform of this bone, like so. And then, as I said, this will positionally be popped into the place of that end bone, but it'll still be world aligned. So I'm just going to take the translation from here and put it into the translation of the spawn control. Okay. And then the other thing here is this needs to be this parent we need to set, because right now it's actually putting it in world space, which we don't want. What I want is to put it into like underneath the local control, these IK controls. So what we need is another input to this function. So we already have like a parent for the FKs, but we need a separate parent for the IKs. So we're just going to click off of this, go to promote to expose pin, and just do a get parent again here. Although it's called _1 until we rename it. We're going to name this IK parent. And we're going to move this guy up with the other parent just so that they're together. And you can see it already changed this because, as I said, using this get node is exactly like the same as connecting it from here over to here. All right, so we have an IK parent, which we need to set, right? We don't have that set right now, so let's actually do that in the construction event. The IK parent we can set to the local control. The problem is we don't have any reference to the local control right now. We are spawning them up here, right? But we're not recording them. So let's take a few minutes to start doing that. We're going to start recording these as we spawn them to variables. And we're going to do this a bit as we go through the setup. But let's start here. Let's start by doing it here. So, oops, 1 second. Just want to give some space here real quick. All right, so to do that, as I said, this output is a reference to whatever control is spawned. So for the global control, I'm just going to click, drag, promote to variable, and then I'm going to just connect this up here. And then in my blueprint, you could see that control that I made down here. I'm just going to rename it to global control. Cool. So now we have a reference to the global control if we need it. But now we want to also do that for the other controls too. So I want to do kind of the same thing. I'm just going to make some space here. And I'm going to dump this to a variable. Connect this up. And we're going to call this one local control. Awesome. And then finally the body control. Whoops. Let me, this is the body control output. That's variable. And we're going to do that. This is a little messy going through the node. You could always add in a reroute node there to make it a little cleaner. We're going to call this body control. Cool. So we have those. I'm going to go down into here now. And for the IK parent, I could just drag in my local control, and wherever else I need like a local control, I now have a reference to it. So I could drag in that variable and connect in my IK parent. So when I do that, and I look at my hierarchy now that IK control that I made is underneath the local control. Cool, so I have that. I'm gonna go back into my construct lim to do the rest of this that we need to do. So first of all, I didn't set this to use global space, so I'll just do that now, just so that it's, if I do anything for querying later, I'll know that that's already set to the global space. I'm just gonna file save that. And then the other things we need to do here are configuring the shape, right? So we're going to go down to here. Oh, and also the name. So let's just do this for now. We're just going to name it IK. That'll change this to IK. And then let's just quickly configure the shape a little bit. This will be a box thick. And that looks like an IK control. Sure. Awesome. So I named this IK. And the problem is, in this rig, I'm going to have other IK controls. So we kind of probably need a prefix that we need to send in to the construct lim to define what part we're making, right? So to do that, I could just drag off of this and say promote to expose pin. And then I can say, well, let me just rename it first. I'm going to rename this prefix. I'm going to put it at the top. I don't know why I like prefix at the top, but I do. So that'll be at the top. And I'm just going to do a get prefix here. So now I'm going to send in a prefix for what part of the rig it's at. And then I'm going to use a concat to combine that with space IK. And then I'll take the result of that and put that into the name. So what you'll see right now is just IK space IK because I didn't send in a valid prefix to this function for this guy. But if I go over to the construction event and go to the construct lim, I could set this as L space arm. And now you have L arm IK for the control. Cool. The other thing I see is that it's red. And also I have no way, I have the FK shape settings, but I have no IK shape settings. So let's actually expose those as well. So we're just going to go from the shape here, go to promote to expose pin. We're going to call this input IK shape settings. And we'll just get rid of the noodle. Like so. Awesome. So we have that. We can go back out to the construction event now, and now we have these IK shape settings. And the one thing that we want to connect is the left side color, right? So I'm just going to expand the IK shape settings and connect in that color. Cool. So we have the IK control. We said we also need a child null, and we need a poll vector. So let's do the null next. The null is going to use a different spawn node. So we're just going to use a spawn null for this. And it's going to be a child of the IK control. So the output of this IK spawn, we're just going to use as the parent of the null. And then what I'm going to show you is what we'll do in 5.7 and further on. And then I'll change it up to attack an issue with 5.6 that I'll explain. So what I want to do here is spawn this null. And the null needs to be exactly like orientation and positionally pinned to that last bone. So that's easy enough to do. We already have the bone, the last bone right here, right? And we are getting the transform right here. So we can just pump this output right into the spawn null, but we want to switch this over to global space so that that will be set in global space. Now we don't, well, let's do the name first, and then we could talk about how to visualize this thing. So for the name, we're just going to use the same prefix. So you say get prefix that we're sending in, and I could totally, and actually, let me just show you this. I mentioned that a uh, a rig element can have the same name if it has a different type, and this is where this comes in here. So if I want the null to also be called LRMIK, I could do that. I could just take this result here from this other concat and put it into the name of the null, and now down here, those are unique. They have the same name, but they're seen as unique in the system, even if they're on the same level of the hierarchy. So that's really cool. So now, okay, we have all these kind of set up and configured here. So how do you see the null? Up in the viewport, there's a little this little eyeball, and if you search for null, there's a little display nulls option. So you can do that to see where exactly that guy is. It'll show all the nulls that you have in this rig hierarchy. So you can see here, it's kind of just it's snapped right to that last bone. And then the other thing though is this again will show all nulls. So if you have a system with a whole bunch of nulls, this might get in the way. So normally I don't have this option enabled. What I do have enabled, so let me just turn this off. What I do have enabled, if you search in that eyeball for axes, I usually have this display axes on selection enabled. What this does is in your hierarchy, if you select something, it'll show you where it is with the axes. So controls, bones. So that's normally the mode that I use most cases. But if I want to see a system of nulls, then sure, I'll put on the display nulls so I can see it there. All right, so back to this, where normally this is what you'd want to do. Like you just spawn it in global space. You're querying something in global space, and that's great and all. In 5.6, there's an evaluation bug sometimes where if something is parented in a certain way with a null, and if the null was spawned in global space. So to get around that for the version of the engine we're using here, what we're going to do is spawn this null in local space, and we're going to do a calculation to get that to be the proper offset. So you can see it's right here. That's where it ended up. Now, if I switch this to local space, it will go to a different location out here, which is incorrect. So we need to calculate this input transform to be a local offset. And to do that, it's pretty simple. You just use a node called make relative. And this takes a global transform and then a parent transform, and then it spits out the relative offset between those. So the global transform will be this this guy here, this full global transform. The parent transform will be the parent that we have this set to, the transform of that. So I could just do a get transform on this, put that into the parent, and now this should be the correct local offset to pump into this transform. And you can see it pops into place then. So this will alleviate any issues with null evaluation. This especially happens when you are saving the level sequence. You'll see the nulls pop into the wrong location. So it's something to keep in mind. Like when you're spawning nulls in 5.6, you might want to do this type of thing with local space. But in 5.7 and 5.8, that has been fixed. Cool. So we have the null here. And the last thing we need to do is build the pull vector control, which we're going to want to out here. Like that's where we normally want the pull vector. So let's make a spawn node, spawn control, because this will be a control, but this will be a different type of control. So instead of making a transform control, what we're going to do is right click and make a vector control, because a pull vector just needs the translation values. So you could see here this new control that was spawned. If you go over to the right, you could only see location values. So that's kind of the type of control we want. Like I said, the engine has multiple types of controls, and for the pull vector, it makes sense just to make a vector control there. Cool. So let's start configuring this. The parent for that will be the IK parent that we have. So get IK parent. That's one of our function inputs. The name, I'm just going to call this, I'm going to get the prefix input. Get that, and we're going to concat that with space PV. And that's will be our name. So you can see it right here, LRMPV. And then the position of it, that's going to be something we're going to have to calculate, right? So this is actually another time I'm going to cheat here. So in my day 2 area, there's a utils function called compute pole vector location. I'm just going to copy that, bring it over here to my blueprint, and paste it. Cool. All right, cool. So this is just a function to kind of calculate a good pole vector location. You can look at this at your leisure, but it does some vector calculations to project to a certain point between the top and bottom bone, and then pushes along that through the middle bone to a certain pole vector offset. But I did want to note that you have like a lot of vector and matrix nodes that you can utilize in control rig here that are super helpful. The other thing to note on here is you see that this entry isn't connected in. There's none of those execute lines. And even on the return node, you don't see that execute line. And that's because I removed them for this. For example, in the conform function, conform name function, you see these execute contexts here. Well, you can remove those. There's little X's by them. But you can only remove those if you don't need any logic, like branching or for loops or things like that. If it's just taking in some inputs, doing some calculations, and then spitting out a value, you don't need that execute context. And what that gives you is if you go into the construct, where are we? Yeah, the construct lim here. It gives you a way, if you bring in the compute pole vector location, to not have to link up these execute lines, because all it is taking in some inputs and doing some calculations. So there's no need for it. But if you do need logic, then you're going to need those connections in there, any branching logic or looping or anything like that, or conditional logic, things like that. All right, cool. So we have this compute pole vector location. It has an output here, has a couple inputs. We do have the bones as an input to the function. So we just do a get bones. Connect that up. And then the secondary axis I know is going to be, if we select the bone, it's going to be negative Z because we want it out here. So we want this to be -1 for the secondary axis for the pole vector. And then the offset, I know a good offset is 50 for this guy. So we're going to do that. And then in the offset transform, again, we want to switch this over to global space. And then we want to connect the pole vector location to the translation. And you can see there that it pops into place into where we'd want the pole vector. Cool. That's really great. Now we might want to configure these guys, right? So we want to probably expose these as exposed pins to the function. And I'll just do that get thing again. Cool. And then after that, we also have some settings here for the shape that we probably want to expose. So what we want to do is take the shape here. Let's configure it first. So we want this as diamond solid. And we probably want to size that down a little bit. So we're just going to go select this guy, click the scale and put this down to, I don't know, 0.5 or something like that. Cool. And then now we want to just expose it. So click on the shape, drag out, promote to expose pin, click on the shape, get shape. And then we want to also rename that. So let's go over to here, rename it to PV shape settings. Let's organize this a little. I want the secondary axis and PV offset above the shape settings, so I'm just going to move those up. Awesome. I'm going to compile and save this. And now that we have those inputs here, if we go out to the construction event, we now have those inputs to configure. Again, for this, we want to link in that left color, and that'll make it blue. That's really neat. And then we have the PV offset. We already configured these, so they're at a pretty good default value right there. So that's kind of all we have to do for that. All right. I think we have a good set of IK controls and the nulls. And I always like to go in, just check my hierarchy, making sure everything looks okay, whether it's named okay, and everything looks good. So now let's make this all work in the forward solve. So if we go into the forward solve here, we have this forward FK. So we're going to do the same thing we did with the construction, where we're going to right click on this and go to collapse the function. And then it gets that new function. We're going to rename that to forward limb. And then we're going to go into that function and just do some little organization. So start with a sequence node, connect this to the B, connect this to A, and then do a get bones from here. Whoops. We are, connect that up. Cool. All right. And actually, I should have made another pin here because we're going to be using the B for the IK. So let's hold down Control, click away, and then release on the C. So that'll move that to the return down to the C pin. And now we can start building out our forward solve for our IK. Now we're going to do this wrong. Not wrong in that it won't work. The IK will work, but it's not going to be a properly working limb. And that's okay. We're going to fix it up. So from the B, what we want to do is use one of our IK nodes, and we're going to use the basic IK. When I make that, you can see a lot of inputs here. It's okay. We can figure this out. These item A, B, and effector item, those are your 3 bones, which we have as an input here. So let's say get bones. And pop, and then we're going to use some at nodes here to get each of those indexes. Just change the index value here. Again, you can use -1 on this last one or 2. Pop that into each of these items and connect this into the arrays. Cool. Now you saw that it broke the arm, and that's okay because we're going to fix it. It's just because not all the inputs are in there yet. We just inputted these bones. We still need to input the effector, the primary axis, secondary axis, and a pole vector location. So for that, what do we have? We have bone inputs, but that's all we have. What we need are some new inputs. We need something that will get me the null so I can get the effector. And then we also need the pole vector control as well. Well, let's go back to the construction or the construct limb here. And let's see what we're doing in here. So we are spawning controls, but we're not recording them in any way. Similar to what we did with the global and local control and body control, what we'll do is we'll dump these spawned controls, references to them, to variables, and then we're going to spit those out of the function so that we can use them later. So let's do that now. We're just going to give this some space. And for the IK, which is right here, we're just going to click, drag, promote to local variable. We're inside a function. So what we want to do is instead of promote to variable, promote to the local area of this function as a variable. And we're just going to connect these up here. Make sure this connects back up to here. And then down in the local variables, you see the list here. And we're just going to rename this local IK control. Awesome. And then let's skip the null for now and go over to the pull vector, and we're going to do the same thing. Promote the local variable. And we're going to name this local PV control. Awesome. All right. And then we said we want to spit these out. So we're going to go over to this return or by this return node here. We're just going to drag these local variables in here and drag out over the return node for each of these. And this is why I called these local IK control and local PV control, because the outputs on a function can't have the same name as local variables. So in here, I'm just going to call this IK control and PV control. Cool. Now for the null, instead of dumping that to a variable, since it's pretty solidly like connected to the IK control in some ways, let's do that a little differently. So here's where we're spawning the null. Let's use that metadata to on the IK control to specify what its effector is. So we can do a set metadata here. Whoops, not add tag. We want to set metadata. There we go. All right, let's give this a little space. All right, so the item that it'll be on will be the IK control. We have that as a variable now, though, so we can say get local IK control and connect that into the item. The name, I'm going to call this effector, the name of the metadata, and then the value will be the null. And there we go. Cool. So we have that recorded. We have the null recorded. We have the IK control recorded and spitting out, as well as the pull vector control spitting out. Now, let's go back to the construction event, though, because we now have these outputs, right, that we want to, from that function, that we want to dump down to variables of the rig itself. So we can click, drag this, promote to variable. And I'm going to connect these vertically just to save some space. Promote to variable. And then just make sure you still connect up those fingers. And then in here, we're just going to rename this larm IK control and larm PV control. This is getting to be a long list here. So let's also do something here to organize our variables. And this is where those categories come in. So we have some setup variables, and then we have some references to like objects of the rig. So for the setup variables, if you select the variable, you can go up over to the right here in category, and you can type in a new category. So I'm going to call this setup. And once you have that category, you can then take any other variables, click and drag them over that, and they'll just pop in to that category. And now you have this little collapse expand feature here for that. And then I want for the references to like bits of the rig and stuff, I want to put this into an objects category, but I also want to have subcategories there for the area of the rig. And to do that, you can type in objects, and then you can use this syntax to create another level. You can use a vertical line, and then you can type in, I'll just call this root. And you can see here, it creates objects and then root underneath. And then you can just click and drag these local, and I'll just put the body under the root category as well. And then you could do the same thing for the arm. You can make this objects, vertical line, larm. And then you can drag the PV control under there. Awesome. So we have those IK controls, the pull vector control being recorded down to variables of the rig that can be used elsewhere, like the forward solve. So like I said, in the forward limb, if I hop back to the forward limb, we're going to need the IK control, and then we'll use the metadata from that IK control to get the null so that we can get this effector transform. And then we get the pull vector as well. So we need a couple new inputs. So I'm going to go over to the entry here. And I'm going to make 2 new inputs. One is going to be your IK control, and this is an array rig element key just because this bones was the last one created. You can use this pull down to make it singular. And I'm going to call this IK control. And then I'm going to make another one and call that one pull vector control, or PV control, sorry. All right, and that's great. We have those in place. And just to note that you don't need to be in the function to add these in. I was already showing you stuff inside the function, but you could also, for example, if you go, let's go to the forward solve. You could just over here on the left, go to forward lim and then do the same thing. You could add like inputs without having to be in the function adding inputs. So I have these IK control and PV control inputs. So let's utilize our newly constructed variables. Just going to drag these over. Put that on IK and drag this guy over here. That onto the PV control. So now I have the right inputs in here. And I can dive into the forward lim and use these now to derive the rest of the stuff. So I can do a get IK control, my input arguments. I can now get the metadata because I want to get that null, right? So that's where the metadata comes in here. And I'll just set the name to effector because that's what I named that metadata. And then the value is going to be the null. So then I just use a get transform to get the nulls transform. And then I pump that right into the effector. And there you go. It fixed the arm mostly. We still need to do some other stuff to get the IK working with the right inputs, but there you go. It's now in the right position there. The other things we got to do is configure the primary axis, which I know is already correct because X is down, positive X is down the arm. The secondary axis, however, is not correct. Just like we did using the construction event, I know that needs to be -1 in Z. And then the pole vector will be the final thing that we want to put in here. And we have that as an input. So we're just going to do a get PV control. And we'll put that into, or we'll need to get the transform from that. And then we're going to expand this transform and just pump the translation into the pole vector. And we want to also set this from direction to location because we are giving it a location for that pole vector. Cool. So now we have that. So now if we move this around, we get an IK arm and the pole vector works correctly, which is great. The one last thing I wanted to do though is make a line from the elbow to the pole vector just as a good visualization as to where that pole vector is. So to do that, I'm just going to break off of the IK, create a draw line node. Now that you can see there's a bunch of draw nodes that you can utilize for visualization. They're super handy for a lot of things, but I'm going to go with the draw line. Draw line has 2 vector inputs, which are positions that we want to draw the line from and to, and then some other configuration here. So for the first, I'm going to need to draw from the elbow, which we have over here. We're getting the elbow bone here, so we can just drag off of here, do a get transform off of that, expand this, and then put the translation into A. And you can see that line already drawing down to the origin. That's because we haven't set up the B yet. Now the B we kind of already have. We got the transform of the pole vector control, and that's where we want the line to draw. So I could just take this translation and put it right into B. And now you have a line here. I'm just going to make the color not like red. I don't want to freak out anyone as they're animating like something's wrong. So I'm just going to make it a gray color. And yeah, and then we compile, save that. And now when I move this around, that line will constantly update between the elbow and the pole vector. Okay, cool. We have a working IK arm. As I said, though, this is wrong because it's stomping on the evaluation of the FK because it's running the FK and then it's running the IK. So the FK kind of doesn't do anything right now. So we're going to fix that in the next session. We're going to take a little break. and then come back and we're going to set up an IKFK switch. We're going to do some auto matching and finish things up a little bit from there, adding in some visualizations or visibility settings and auto keying. All right, so before I go into setting up the IKFK switch and auto matching and auto keying and visibility stuff, I want to take a few moments to set up. We have this arm set up, but now that we have all those functions, there's not really any reason we can't set up this right leg. So we're going to do that now. I'm in my construction event, and I'm just going to make a new pin here, and I'll just take this whole thing and copy and paste it down here and call this construct our leg. And we need to first get rid of some things. Like these are arm variables, so we're going to have to create some leg variables. Let's see, the arm bones, we're going to need some leg bones. So the local control going into the IK parent is fine for the IK parent. And the left side color is also something that we're going to need to alter. So because this is the right side. So we're going to start with this and we're going to connect things up. We're going to just connect the C up into here. And now the bones we're going to need, like I said, we need those leg bones, right? So we're going to do the same thing we did with the arms. We're just going to select actually, we're going to select the left side because I'm going to use my left side to be like the variables and then kind of alter that list to do the right side. So that when I'm doing the left side, the other arm and the leg, it's kind of consistent. So I have my three left leg bones here. I'm going to drag them in and say create item array. And I'm going to dump it like I did before to a variable. And this is going to be called leg bones. And we're just going to bring that up to the setup area. So we have them there. And I can get rid of the item array. So now I have this variable here. But these are the left bones. So what I'm going to do is clone it to make it a unique list. So I'm not editing this list, but I want to kind of convert it over to right side list. So I'm going to clone it, and then I'm going to use a function called replace items. And I'm just going to replace L underscore with R underscore. Now, you can do this with other ways. You can have functions that do this to create a right-sided list. I wanted to show you as many types of nodes in this demo. So as I'm making this rig, it's not exactly how I would specifically make a rig out. It's really trying to cover a breadth of different nodes and how they might be used. So this will replace the right side with the left, or the left side with the right side. And then I'm going to put that into my bones input. I also need to change the prefix to our leg. And the parent is not going to be the clavicle. It's going to be the hip there. And yeah, let's see what else. And then let's compile this and save it. So we have our controls built. They look pretty good. Actually, the secondary axis input is going to be the same as the left arm because we want it here, and that'll still be a -1 in Z. So that's great. And the PV offset is also the same. Now this shows up in red because it's that's the default color. But I do want red to be my right side. And if I'm using it elsewhere, I kind of want to get this left color that I already have. I want to duplicate it, Control D, call it right control color, and then connect that in just so that it's using that variable. So I can connect these into the colors inputs here. Won't change anything with the visualization of it, but it's now using the right side variable. Cool. So we already have everything created. Let's just make sure. Yep, our leg IK, our leg, yep, our leg PV. Awesome. We already, again, have all the metadata in place because we already did that in the construct limb. So now let's go over to the forward solve. And we're going to do the same thing here. We're going to take this guy, copy, we're going to paste it. And we're going to connect this up. Oh, need to make a new pin. Connect this up. And let's see what we want to do here. We don't want the arm bones going into here. We want the leg bones, which we have right here. And then we need these are the arm variables. So we need some new variables. So if we go back to the construction event, we got to dump these outputs on the leg construct limb down to variables. So let's just quickly do that. And again, we're going to just connect these in vertically. And go down here. Rename this to R leg IK control. And R leg PV control. And we can put these under categories. Trying to make up some time right now, so I'm not going to make categories for the L leg particularly, but you do the same thing for the L arm. All right, so we have those in there. So now we can just bring in the left IK control, pop that into place, and then the leg PV control, connect that up to here. You know, and, yeah. All right. Oh, and also we're gonna need some different things here. Hold on 1 second. Control, yes, arm control, that is correct. Just making sure that we're getting the right, dumping the right controls in to that. And we have the leg bones. Good, good, good. Cool. So let's go over to forward solve. And one thing we need to set though is we need to expose the secondary axis, right? And the primary axis so that we can configure those. And we didn't do that in the last session. So I'm just going to promote to expose pin here and also do it for here. And I'm just going to get that. Primary axis, so that we have those as inputs to the leg, like so. And so now we have these here. They're in the right order. That's totally fine. So that's cool. So we're just going to copy that. And we're going to go over to the forward solve and the primary axis on the leg. Although I see that it's using the wrong bones, so I probably have. Oh, I'm using the left leg bones. Duh. Sorry. So what I need to do is change these, like I did within the construction event. I need to change those over to the right side. So I'm also going to change this to R leg. And then I'm gonna, again, just like I did with the construction event, clone this list. Again, you could do this once and dump it down to right side. I just wanted to show you the replace items and how that works and just use it the same way in both here. And I'm just gonna replace L with R and connect that up to the bone input. Cool. And you see now it's using the right side bones, but it still looks broken. Looks very broken, and that's because we didn't configure the primary axis on this guy. So I said with the construction event, the secondary axis is the same as the left arm, just how the joints are oriented, but the primary axis needs to be flipped because the negative X on this side is going down. So we need to change this to -1. Cool. So now we have a right side leg. The only other thing we got to do here is actually we didn't connect up or set the right side color correctly. So we made it, but we didn't set it correctly. We just duplicated it and left it as blue. So I'm just going to select the right side color and change this to red. There we go. Cool. So we have a right side leg now, all colorized, all the controls are there and working. And if I select the IK control and move this guy, it should work just as the arm does. Awesome. All right, so we have the leg set up, which is great. But now, as I said, in the forward solve, this forward limb is incorrect because the FKs are no longer doing anything, the FK solve. So we're not going to be using a sequence here to just do A, then B. What we need to do is like say, okay, if we're in this mode, evaluate this branch, and then if not, evaluate the other branch. So we're going to start with a branch node here. And I'm just going to disconnect the completed and connect, well, yeah, let's think about this for a second. So I'm just going to break this link. So we have this branch node. So we're going to create an input to this function. That will be the IKFK mode. And if it's IK, that Boolean will be 0. If it's FK, it'll be 1. So if you think about that, if this condition is true, we want it to run the FK evaluation. If it's false, 0 for the Boolean. You want to run the basic IK here. Okay. So we have this branch here. So now if I compile and save, let's go back up to the arm, I guess. It's at 0. So this will work as it was before, the IK, right? But if I switch it over to true, it'll snap to the FK and it'll evaluate the FK controls. Great, but now we need a way to for it to tell which one to run. So this is where we're going to go in and we're going to spawn an animation channel. That'll be the IKFK switch, and then we're going to use that in this branch to actually do the switch. So to do that, we're going to go to the construct limb function. And after we construct the IK, just going to make another pin here. I'm going to hold down Control, click, drag, and release on the D just so that the return is still there. And I'm going to go from the C and I'm going to use a node called spawn animation channel. So we're going to make this guy here. Now let's take a look at this node. It has a parent, which is the control that you want this channel on, the name, which is, the name of the channel. And then you see these gray values again. It's a wildcard. So you can make different types of channels. In this case, we're going to make a Boolean. So I'm going to right click and select Boolean in the pull down, and that'll fill in all those others. As for the name, I'm going to call this IKFK switch. And for the parent, I want this to natively live, I guess, on the IK control. And we already have a local IK control variable in this function. That's a reference to it. So we're just going to use that and pump that into there. And now we're going to compile and save this. And now when I select this IK, you now see down here in the animation channels an IKFK switch, which we can use now. But right now it's just a spawn. We're not dumping it to any variable. So let's do that so we can utilize it in the forward solve. So just like with controls, you can take channels and dump those to variables. So I'm going to promote this to a local variable. We're going to call this local IKFK switch channel. And then we're going to spit that out here. We'll call this IKFK switch channel. Awesome. So we have that. If we compile and save, we can go out to the construction event, and now we have this IKFK switch channel. Bring this up, give some more space. And we want to dump these output, this new output on both of these to the variables for the left arm and the right leg. So we're going to do this, promote to variable, link this up. Do the same thing here. Link that up. And then down here, we're going to rename this guy to left arm IKFK switch channel. I know my names are long, but you can do whatever you want for your variable names. And right leg, R leg IKFK switch channel. All right, cool. I already have this category for L arm, so I'll drag that into there. You know what? I'll just make a category for this. It's because it's bothering me. So I'm just gonna go in here. Objects, vertical line, R, leg, and then we're gonna drag these guys underneath here. Cool. All right. So we have the variables set now, which is awesome. Now in the forward solve, what we're going to have to do is input this into the forward limb, this channel. So if we select the forward limb, I can make a new input here. This will be a rig element key. Call this IK FK switch, you know? And it's important to note that this is a rig element key, just like a control or a bone or a null. An animation channel is just that, has a type and a name. And then we're going to move this up to the other rig element keys. So we have that. And now we can utilize that new input with the variables. The L arm is up here though. So I'm just going to link that into the L arm, and the R leg goes right here. All right, sweet. So we have that in place. So let's go into the forward limb. And now we can use this. We can use that to connect into this condition. So what I want to do though is I want to dump the value of that channel to a local variable, because I could query it in the different places in the graph, but I don't want to do it multiple times. I just want to kind of cache it down to a Boolean variable and then reuse it in the rig. So to do that, I'm just going to do a get IKFK switch channel, and then I need to query the value. And to do that, you need to use the get animation channel from item node. So that takes something that you set once you spawned a channel and set it as a rig element. You could put it into this node, and that'll get the value of that channel, right? And now I can dump this to a local variable, right? So I could right click on it because I know it's a Boolean to specify that it's a Boolean, and I can dump this down to a local variable. And maybe I do that first before I do anything. Sometimes we do that to gather like values for variables and stuff, is have a single line of that happening before the sequence node. And then down here, I'm just going to call this local IKFK mode. All right, so now that I have that over here, I can actually, whoops, not there, right here. I can drag this over into here and then connect it up to the condition and compile, save. So now if I move this around, go over here, change my channel, it'll pop to the FK and evaluate that. Now we might want to have a certain mode on first, right? Like at the arms, we might want the FK, and the legs, we might want IK. So we could do that really quickly. What we need though is in the construct limb, we need another input to specify the initial IKFK mode. So we're just going to make a new input for this guy in the construct limb. So I'm just going to go over and make one of those real quick. And let's go reflect that. And this is going to be a Boolean. And this will be, I'll call this initial IKFK mode. Cool. And I'll move it up above the shape settings. And now that we have this in here to specify, I can, in the construct limb, if you look down where we're spawning that animation channel, you have this initial value. So now you can just do a get initial IKFK mode and put that right into the initial value. Once that's in place, in the construction event, say for the, let me just collapse these real quick. So for the arm, I might want this as FK. So we'll just make this true. And then for the leg, we'll keep it that false. And because of that, if I move the IK right now on the arm, nothing happens because FK mode is on currently by default. And you can then switch over to the IK by selecting the IK control and switching back. But as you saw, I don't want to do that. I want that same channel on the FK controls, right? So I don't have to keep hopping controls. So let's actually work on doing that. It's pretty easy in Control Rig to do it. So I'm just going to go into the construct limb here. And after I spawn, I'm going to use a node. If you search for hosts, there's a node called set channel hosts. So this takes a reference to the channel, which we already have right here. And then it has a list of rig elements to kind of host that channel. So it natively is on the IK control, but we can give it a list of other controls for it to kind of be hosted on. So let's build that list. What do we want this on? We want this on the FK controls. We want it on the pole vector control, maybe. So let's start with the FK controls. The problem is we don't have any FK spawned FK controls being recorded. So let's hop into the construct FK and let's do that. After each spawn of the FK control, I want to add an element to an array that's kind of keeping track of the spawned controls. So for that, I'm going to create a local variable that is an array of rig element keys. So if I make a new local variable and I call this current, or sorry, let's call it controls. And we're going to make this a rig element key. Oops. There we go. Rig element key. And we're going to make this an array of that. You can do that over here. You could also hold down Control and right click on here, and it'll switch over to the array. So you can do it in either place there. So now I could use this controls to build a list of spawn controls. So I'm going to drag this controls into here. I'm going to use an add node that adds an element to the array. And the element that I want to add is the spawned control. So I'm just going to drag this over to here. Now, if we're using an array like this and we're using this add, a good practice is over on the start of the function to kind of reset it just to make sure it's totally empty and initialized. So we're going to do get controls, and we're just going to make a reset node here. And we're going to connect this up. All right, so now we have our list of spawned controls that are being accrued here. And we want to spit this out, right? So we're just going to go down, drag in. Oh, and actually, I should call this local controls. Sorry about that, because we want to spit it out of the function. So I'm just going to rename that to local controls, say get local controls, drag this over to the return, and then we're going to rename this to controls. Or yeah, controls is fine. Cool. So now we have that outputted. So if we go back to the construction, the construct limb, we now have this fresh new output here to dump to a variable or a local variable in here. So I can promote to local variable, connect that up, call this local FK controls. Awesome. So we have that now. Now we have it. Before we forget, let's actually spit it out because we want to probably spit it out like we do here. Drag that in, drag this over to the return, and then we're going to name this FK controls. And I don't know, I like the FK controls first, so that's what I'm going to be doing. All right, cool. So we have this spitting out. We have to remember to dump that output to a variable in the rig, but we'll do that after we get some hosted channels on here. So we have the FK controls now as a local variable. So we can just say get local FK controls. And we're building this list for the host. So we're going to clone this so we don't alter that list. And then we're going to use an add right here to add to that cloned list. I'm just going to connect this into the execute. And then the other element we want to add here is the poll vector control. So we can just do that. We have a variable for that too. Get local PV control, and we'll just connect that up to the element. And then from there, we just connect the output to the hosts. And you can build whatever list you want of controls. But now if you select the poll vector, you'll see the IK/FK switch on there, as well as any of the FK controls. And also it still is on the IK controls. Now on the hosted controls, or the control hosts, you'll see it in italicized text. That means it's hosted. If you go over to the IK, you don't see that. It's just normal text. So that's how you also visually know what's going on there. Okay, cool. So we have that in there, and now that'll still work. Oh yeah, this is on FK by default. So if I do this and I go over to that hosted channel, it still works as the normal channel. That's pretty cool. I'm gonna turn on and off and on my headset just to make sure no one's trying to ask any questions or anything. 1 second.
They're good. There are 2 questions in here though.
Okay, I can hear you. Anything coming up or good
So
to
the 2
continue?
questions we do have right now are, what does replace items do exactly? Is it just modifying the string keys of the array joints passed in the execute?
It's replacing the references of the items in the list. Yep. You don't have to use that node. I just thought I'd like show it. Like it's a node that you can use, but that's what it does. It has a search replace, and if it finds those new items, it'll replace them in the list, and that'll be the new list that it's outputted. That makes sense?
Yes. And then the next question is, if you use a float value instead of a Boolean, I presume it wouldn't blend the IK and FK, as the bones wouldn't be interpolating between the values?
Exactly. Yes. But we're going to be setting up some auto matching next. And that's why we're just using a Boolean here. But you could totally use a float and set up your rig to interpolate and blend between IK and FK.
Awesome.
Cool.
And then finally, the FK or the IK/FK switch is set in the construction script, and that value is then set in the forward solve. How can we switch IK and FK during animation then, or did I miss something?
That's what the channel is for. So when we spawn these channels, this is what's exposed to animation. So on any of these controls, animators can change this. This will show up in sequencer as a channel that can be keyed, and you could switch between IK and FK. Does that make sense? So for example, right now, if I add this to, let me make this bigger. Sorry about that. If I add this guy to a level here and it loads up sequencer, if I zoom in on that and you select one of the controls here, you'll see that that is a channel that it can be keyed. So you'll see it over here as well in the anim details. Okay.
Cool. That's it.
Awesome. All right, cool. So yeah, what did we just do? We just we just hosted this on multiple channel or multiple controls, which is really neat. So now we could switch between IK and FK modes, and we have the ability to do that on various controls. So now what I want to do is set up what we just talked about a minute ago, some auto matching. So if it's in one mode, I want to match the other mode constantly. And if it's in the other mode, I want to do the reverse. Like I want to keep matching that as you go. So we're going to start setting that up. To do that, oh, I forgot. I said we shouldn't forget this. Because we have this new FK control output off of the construct, we'll probably want to dump this to a variable first, just so I don't forget it to do it later. So we can keep track of those. And again, my graph is really messy. I'm trying to make up a little bit of time here. I know we're pretty short on time, so I'm just going to call this LR controls. and our leg FK controls. Whoops, if I can type, which I normally can't. There we go. All right, so I'm going to drag this up to L arm, drag this to our leg. All right, cool. We have that now being recorded. Awesome. So now let's go in and start doing some matching. So if we go into the forward limb, if we look at this, it's going to be evaluating this branch or this branch. So what we want to do is if it's evaluating this branch, we want to match the IK controls to the result of that forward evaluation. If we're in this branch, when we're evaluating the IKs, we want to match the FKs. So we're going to do this one first, just because I want to show you just how easy it is to build that match function. We already have this, this forward solve or forward FK function, right? So we're going to make another function that's very similar to this, just kind of reverse, because the forward solve is the controls are driving the bones. We want to do the same kind of thing, but we want the bones to drive the controls. So we're just going to copy this, and we're going to paste the function. And we're going to call this backward FK, not match or anything like that, because we're going to be using this in the backward solve. It's exactly what we need for a backward solve. If you remember, that backward solve is where the bones dictate where the controls should be. So we're going to do that here. So the only thing we got to change here is we're looping through bones still. That's totally fine. But we want the bone to be the parent or driver of the system, and then the control to be the child or driven of the system. So we're just going to swap the inputs. So instead of this going into child, this will go into parent for the bone. And then again, this output is spitting out the control. So that'll be the child. And then we want to swap this guy as well, so that the bone, we're getting the transform from the bone. And then we're setting transform not on the bone, but on the control. So when you compile and save that, and now let's try to use it. That's it. That's what we need for the match. So if we go into the forward limb, and like I said, over here, after the IK is done, I'm just going to go to backward FK, drag that in. It does have an input here for the bones. We have that as an input for the function. So I'm just going to get that, put that into there. And we should have, we compile and save on the arm, or sorry, not on the arm. Let's do the leg because that's IK by default, right? So if we move the leg, you should see now the FK control is moving or being driven into place. And then when you switch it, your FKs will be in a position that you can move like that. Now, what we want is now the IKs to match while you're in this FK evaluation mode, right? So we have the FKs, that was pretty quick. The IK, we're just gonna kind of make a backward IK function now and work out what that would be. So we're gonna start with the backward FK, why not? So I'm gonna copy, I'm gonna paste this function. I'm gonna call it backward IK. In this function, I'm going to be deleting most of this because this is just going to be, actually most of this, yeah, will go. But I just still want like the sequence node in there and stuff. And I don't need to maintain offset, so I'm just going to remove that. So we just have a bones input, and then now we got to see how we want to match this. Well, we need to match the IK control. So we need a set transform for that. We also need the IK control, which we don't have right now, right? So I'm just going to go off of the set transform, promote to exposed pin, and then rename this to IK control. And then, yes. Okay, cool. So we have that. Now, how are we going to set this? Well, we need to set it to that last bone, but these have different orientations. So if you remember, we use the project to new parent node in those instances. So I'm going to make a project a new parent here, and we're going to need the transform of the third bone. So we're just going to do a get bones here. Do an at. Remember, -1 is last in the list. And then, so the bones here, so we're gonna use this as the parent, the driver of the system. And then the child will be the IK control. And then this output transform will just link in to this value here for the set transform. So if I compile and save that, let's go up to the ARM because that's in FK by default. What we should be seeing now is, oh, we didn't, we made the input, but we didn't put the input into as the input for the function in the forward limb. So let's go back to the forward limb. Where are we? There we are. We made this backward IK. That's what we were writing. We want to link this up and we want to get the bones. Link that into the bone input. And then we have a variable for the IK. So get IK control, that into there. And now you see it pop into place there actually, but I'm going to compile and save. And now what you'll see is the FK will drive the IK into place. And then if you switch it, then you can move the IK. So that's the IK control, but we need to do the pull vector. So let's go and do that. I'm just going to make a new pin here for doing that. And what we're going to do is, well, we need a pull vector control. So let's make a new input here and call it PV control. So we need to set that. Awesome. And now we're going to be setting this transform just like we did with up here. But how are we going to do this? So let's make the set transform node here. And actually, we're going to get PV control. And we're going to connect this up. All right. So we need to set this transform. We need to figure out where this needs to be after the FK is posed. Well, we do have a function for this. We used it in the construction event. So let's try to use it again here. We have this compute pull vector location. So if we drag that in, we already have bones. So let's get those as part of this. And then we don't have these here, the secondary axis or PV as input. So we're going to need these, but let's configure them first. So I know on the secondary axis on the arm, we have a -1 for Z, and I know the pull vector PV offset is 50. And then we just feed that into the value here for the set transform for the translation. So if we compute or compile and save that, we get this in place here. So now if we rotate this, oh, we need to bring in the pull vector. That's why it's not doing that. So you got to remember, you can't just make the input. You got to actually bring in the actual pull vector control. And we have a variable for that in this function already. Just gonna link that in. And now you see it pop into place. So when I rotate this, it matches that because it keeps kind of calculating it. And then you can move this and it moves the FK and then it calculates the pull vector again when it switches over to IK. We do probably want to set up or expose some things here like the secondary axis and the pull vector or PV offset. So let's do that. Mode to expose pin. Mode to expose pin. Get secondary axis. That PV offset. There we go. So let's compile and save that and go back to the go back to the forward or the forward limb, but now the backward IK has these options. We have a variable for the secondary axis already for this, so we can do that. Now we don't have one for the PV offset, so we can just promote to expose pin for that and get PV offset. I know it's a little messy. I'm running short on time, so. And then on the entry, I want to move these up above the, actually, no, I want to keep them, sorry about that. I want to keep them there because I want the rig element keys there. So this is all okay. All right, I'm going to compile and save this. So now we have the ability, or we have the auto matching happening here. Now, that's really cool and all, but what we want to do is also preserve that pose. So we're going to need a way to kind of request an auto key when a switch happens on that mode. So we do have a node for that. I'm just going to use this B pin that we're not using here. I'm going to go down here, and we only want to request auto keying when we need to do it. And that's only when the IK mode changes by the animator. If they're scrubbing in sequencer, we don't want to be spamming auto key requests. So we're going to start with a branch because we don't want to always do this. We need a condition to compare like a previous IKFK mode with the current one. And if it's true, we're going to use a if you search for send event is the node. So search for send, it should come up to send event here. So let's take a quick look at this node. This has a couple modes. The default is request auto key is what we want. It has an item to request a key on, so that would be whatever controls. And then there's some other configuration. The one thing you want to keep on is only during interaction here, because we don't want, again, we don't want things changing when we're scrubbing through sequencer. So only when they're actually interacting with that and changing that channel is when we want that send key to happen. Now I notice there's only one item here, and we don't want to just key one control. We want to key a set of controls. So we're going to put in a for each here. And we're going to connect this up to here. And we're going to have to build a list of controls and then loop through those and then key each one. So the list of controls will be the FK controls, the pole vector, and the IK controls. Unfortunately, we don't have the FK controls as an input, so we're going to have to do that. We're going to have to go back to the forward solve. And for the forward limb, I want to add in another input here. That will be FK controls. And we're going to call this rig element key. And we're going to make that an array. And we're going to move this up with the other ones real quick. Okay, cool. And then we already have variables for this. Remember, we dumped them out. So that's great. We can go and get the leg FK controls here. And we can up here get the arm FK controls. And then if we go down into the forward limb, now we have that input. We can go down here and say get FK controls. And we're going to use a clone again because we're building a list of controls that we want to key. And this time we're going to use an append because what that does is it appends another list in. So we want to also do that. Give this some, oops, give this some space. Bring this up. Maybe that's too much space. Connect this up. And we're going to connect the output of the append into here, but we're going to manually create two entries here. And we're just going to link in the IK control, which we have as an input, and the pole vector control, which we have as an input. All right, and so we have our keyed stuff. Now, after we key our controls, we also want to key that channel. And you can put this in the list to key, but I just want to separate it out to another send event. And then in here, we have that IKFK channel that we want to make sure is keyed when that switch happens. Cool, so we have that. Now the problem is we still need this condition. So we have a local variable in here. Whoops. We have a local variable in here called local IKFK mode. which will be the current value of the IKFK mode, but we need a previous, and we're going to just use a not equals to kind of use as the condition there. All right, so we need this to fill in this. So how are we going to do that? Well, we could build out some variables to track a previous, so we can build out a bool variable and track that previous IKFK mode value through the functions so that we set it every time, say, an evaluation goes through, and then we set it as the new previous value, and then we can compare that. But what we're going to do here, I want to show you that you can add metadata to animation channels. So in the construction or in the construct lim, where's my construct lim? Maybe I'll just go over here to it. When we're spawning this channel, let's set some metadata on this guy. So we're going to use the set metadata node. The item that it'll be on will be the channel. So from here, we're just going to do this. The name I'm going to call previous value. And the value is going to be, right now, let's start it at the initial IKFK mode. And then every time it evaluates, if something has changed, then we want to switch it to the new previous value. So we have this Boolean metadata set up now. Let's save that. And now in the forward lim, what we can do is get that metadata. We can just we can just get the IKFK switch channel, get metadata, select previous value, and that will be the previous IKFK mode value that we'll be comparing. So we'll put that into the B here. Now, if we get into this and it has changed, right? We go through this branch of true and we do these key requests. And then at the end of that, we want to overwrite whatever is currently in that previous value with the current one, because it's going to be a new previous value. So from here, from this last send event, I'm just going to use a set metadata. And the item is going to be that IKFK switch channel. The name, it's going to be previous value, and the value will be the current local IKFK mode. So you're kind of overwriting that previous value metadata as you're, you've changed something. So if we did everything right, only when an animator changes that mode will it do the auto keying and then overwrite that previous value so that it can track the changes on that channel. But let's test it out real quick. So we're just going to, let's get rid of this real quick and get rid of this guy. I'm just gonna drag this into my scene here. Let me save this just so I have it. Okay. I'm just gonna browse to it here, what I'm working on right now, drag it into here. And now when I move this around, so say when I move I don't see any keys initially on here. You'll see little dots. But if I rotate this, right? And then I go over here and change the mode, you'll see those keys show up. So it knows that has changed, and so it's setting those values. So now I'm in IK mode, and then I can change it up like this, and then switch that, and then you get the key. Oh, well, let me change the value. Here you go. So I could change the value, you get new keys. We can go over here, change the value, get new keys. But if you're scrubbing, it doesn't do it. It's only when you're changing the value that it'll do that. Okay, so we have a couple minutes. It's going to be 2 minutes over. I hope that's okay. I'm going to just quickly show you visibility, because as you can see, all the controls are on at all times. So this will be real simple. I'm just going to add another pin here. I'm going to move these down by holding down Control. And then from the A, I'm going to create another sequence here. And I'm going to have 2 for loops, one for the FK controls, one for the IK controls. So we have FK controls as a variable. Or as an input, sorry. And we're going to put that into the FK control loop. And the IK controls, I'm just going to manually add options or entries, and I'm going to say get IK control and get PV control. Put those into here. And we know the mode, we know the IKFK mode. So let's get, that's our local, get local IKFK mode. So for each of these, we're going to use a node called set control visibility. Just going to duplicate it for the other one. Going to connect the element of the for loop into the item input of the set control visibility. And now I'm going to use this value, this current IKFK mode value. So if it's 0, it's an IK mode. So we want the FK controls to be off. So I can connect this, that'll be 0. So I'll connect that into the visibility of the FK controls. And then if it's if it's FK mode, it'll be 1 for the Boolean or true. So we want to use a not node and link that into the visibility of that. And you can see it already worked. So the leg has the IK, the arm has the FK, everything else is invisible. And then if you pose and you change the mode, you now have your IK controls. Move those, and you can keep doing that. Okay, cool. I think that's it. I didn't have time to go over spaces or anything like that. I would take some time if you're doing this part of the demo to first work on building out the other arms and legs, but also to take some time to clean up the graph like I was showing a little bit of, but didn't have entirely enough time to do it properly. All right, thanks a lot.